Good day, this is Roselyn Jakosalem. Welcome to our video tutorial. In this video, we will talk about the collection of data. So before we proceed, let us define first the collection of data. Collection of data is the first step in any statistical work after the formulation of the problem. It measures the information on variables of interest in an established systematic fashion that enables one to answer stated research questions, test hypotheses, and evaluate outcomes. Data may be gathered by the following methods: interview, questionnaire, observation, registration or census, and experimentation. So the first method is interview. This method is referred to as the direct method of gathering data because this requires a face-to-face inquiry with the respondent. These can vary in formality, from informal chats to structured interviews. The second method is questionnaire. This method is referred to as the indirect method of gathering data because this makes use of written questions to be answered by the respondent. Questionnaires and surveys can be used to ask questions that have closed-ended answers. To be meaningful, surveys and questionnaires need to be carefully planned. Unlike an interview, where a researcher can react to the direction of the respondent's answers, a poorly designed questionnaire will lead the study nowhere quickly. While surveys are often less expensive than interviews, they won't be valuable if they aren't handled correctly. Surveys can be conducted as interviews, but in most cases, it makes sense to conduct surveys using forms. The third is observation. This method makes use of the different human senses in gathering information. It involves collecting information without asking questions. This method is more subjective as it requires the researcher or observer to add their judgment to the data. But in some circumstances, the risk of bias is minimal. In general, observation can determine the dynamics of a situation, which generally cannot be measured through other data collection techniques. Observation also can be combined with additional information such as video. The fourth method of collecting data is registration or census. This method requires the enactment of law to take effect because it needs the participation of a large, if not the entire, population. In a census, data about all individual units are collected in the population, while in a survey, data are only collected for a sub-part of the population. This part is called a sample. These data are then used to estimate the characteristics of the whole population. The fifth method of data collection is experimentation. This method is usually conducted in laboratories where specimens are subjected to some aspects of control to find out cause and effect relationships. An experiment is a controlled study in which the researcher attempts to understand cause and effect relationships. The study is controlled in a sense that the researcher controls how the subjects are assigned to groups and which treatments each group receives. Data gathered may be classified as primary or secondary. Primary data are information gathered directly from the source, and secondary data are gathered from the secondary sources such as books, journals, magazines, or theses of other researchers. So here's the Sloven's formula. N is equal to N over 1 plus NE squared, where small letter n is the number of samples, and the capital N is the number of population, and E is the margin of error. For example, What is the sample size if the population is 3,000 and the margin of error is set at A, 5% and B, 3%? So here's the solution for the margin of error is at 5% or 0.05. Thus, we will use the Sloven's formula, which is n is equal to n, which is the number of population, over 1 plus n e squared. So let's substitute the given values. For n, number of population is 3,000 over 1 plus 3,000 times the margin of error, which is 0.05 squared. So 3,000 over 1 plus 3,000 times 0.0025. So we will get 3,000 over 1 plus 7.5. And n is equal to 3,000 over 8.5 or 352.94. Therefore, the sample size at 5% margin of error is 353. For the margin of error is at 3% or 0.3, hence we will use the same method of getting the sample size. So substitute the given values to the formula, wherein 3,000 is the number of population and 0.03 as the margin of error. So we will have n is equal to 3,000 over 1 plus 3,000 times 0.03 squared. So we'll have 3,000 over 1 plus 3,000 times 0.0009, and we'll get 3,000 over 1 plus 2.7. So n is equal to 3,000 over 3.7, and the answer is n is equal to 810.81. Therefore, the sample size at 3% margin of error is 811. The given example suggests that as the margin of error is set at a smaller percentage, the number of samples gets closer and closer to the number of population. Note that a certain degree of error is committed when samples are used instead of the entire population. After determining the number of samples, the next thing to do is to know how these samples will be gathered and what factors are to be considered in getting these samples. There are different sampling techniques, and the purposes of which vary from one another. The first is probability sampling. It is a sampling procedure where every element of a population is given an equal chance of being selected as a member of sample. It involves random selection, allowing you to make statistical inferences about the whole group. Probability sampling includes random sampling. This basic sampling procedure may be done by lottery or with the aid of a table of random numbers or the random function of a scientific calculator. For bigger population, computers can be programmed to randomly select the samples. In a random sampling, every member of the population has an equal chance of being selected. Your sampling frame should include the whole population. To conduct this type of sampling, you can use tools like random number generators or other techniques that are based entirely on chance. Then we have systematic sampling. This is an alternative to simple random sampling, especially when the population is too big that random sampling becomes tedious. Random starting point is selected from the list of population. The samples are determined by choosing every nth element on the list until the desired number of samples are drawn. For example, all employees of the company are listed in alphabetical order from the first 11 numbers. You randomly select a starting point, number 2. From number 2 onwards, every third person on the list is selected. So, you have 2, 5, 8, and 11. If you use this technique, it is important to make sure that there is no hidden pattern in the list that might skew the sample. Then we have stratified random sampling. This is done by creating different classes or strata within the population. The grouping may be done based on grade level, income groupings, and gender, among others. It allows you to draw more precise conclusions by ensuring that every subgroup is properly represented in the sample. So the fourth type of probability sampling is cluster sampling. If the population is too big, a sampling method may be employed to a smaller area. The population may be divided geographically into regions, divisions, or districts. To these smaller areas, other probability sampling procedure can be employed. It also involves dividing the population into subgroups, but each subgroup should have similar characteristics to the whole sample. Instead of sampling individuals from each subgroup, you randomly select entire subgroups. If it is practically possible, you might include every individual from each sampled cluster. If the clusters themselves are large, you can also sample individuals from within each cluster using one of the techniques above. This method is good for dealing with large and dispersed populations, but there is more risk of error in the sample, as there could be substantial differences between clusters. It's difficult to guarantee that the sampled clusters are really representative of the whole population. So non-probability sampling is a sampling procedure in which not every element of the population is given an equal chance of being selected as sample. The drawing of samples is based purely on the researcher's objective. This type of sample is easier and cheaper to access, but it has a higher risk of sampling bias, and you can't use it to make valid statistical inferences about the whole population. Non-probability sampling techniques are often appropriate for exploratory and qualitative research. In these types of research, the aim is not to test a hypothesis about a broad population, but to develop an initial understanding of a small or under-researched population. There are three main types of non-probability sampling. The first is convenience sampling. The researcher's convenience is the primary concern in using this method. For instance, if the convenience of having internet connections will be considered, not every element of a population is given the chance to be chosen as a sample, since not everyone has access to this technology. A convenience sample simply includes the individuals who happen to be most accessible to the researcher. This is an easy and inexpensive way to gather initial data, but there is no way to tell if the sample is representative of the population, so it can't produce generalizable results. The second type of non-probability sampling is quota sampling. This is similar to stratified sampling, but the drawing of samples in quota sampling is not done randomly. If the desired quota is reached, the drawing of samples is terminated. Quota sampling is defined as a non-probability sampling method in which researchers create a sample involving individuals that represent a population. Researchers choose these individuals according to specific traits or qualities. They decide and create quotas so that the market research samples can be useful in collecting data. These samples can be generalized to the entire population. The final subset will be decided only according to the interviewer's or researcher's knowledge of the population. The third type of non-probability sampling is purposive sampling. This is used when the specific objective under study requires a particular sample which may not cover the entire population. This type of sampling involves the researcher using their judgment to select a sample that is most useful to the purposes of the research. It is often used in qualitative research where the researcher wants to gain detailed knowledge about a specific phenomenon rather than make statistical inferences. An effective purposive sample must have clear criteria and rationale for inclusion. And I guess that's it for this session. I hope you gained something from this video. Thanks for watching!